Hello everyone. For this tutorial video, I'd like to explain how you can use the limit comparison test to figure out values of some infinite series that you would not be able to figure out with a simple formula, nor with an integral. For example, if we wanted to find the infinite sum of this function, we would see that an integral would be difficult, if not even impossible, to figure out. So we would have to use a different method. We see with some creative thinking that this is lesser than the function as if you did not have the plus n in the denominator, because of the fact the denominator is smaller in the second function than the first function, and so the value is greater. We chose this function because there is a formula for it, as it is a geometric series. We plug in the appropriate formula and it evaluates to 3/2. So we go back to the original function, rewrite it as partial sums, see that because we know the finite value of the function we are comparing this to, it follows it must also be finite since it is less than this value, without being so small that it approaches negative infinity. In conclusion, this series is convergent because the series we compared it to is also convergent. So now, if we were asked to figure out a more complex series such as this, we would see that n over n squared simplifies to 1 over n, which is a geometric series, and see with some careful reasoning that the original series asked in this problem is greater than 1 over n, because of the fact the denominator is smaller than the function we are comparing it to. However, the catch with this particular geometric series is that it diverges rather than converges, as you might expect. So because it is greater than an infinite or divergent series, it must also be divergent. So this is what we conclude. In conclusion, if we can figure out a limit we can compare it to and calculate, we can figure out if a complex limit is convergent or divergent. However, like with integrals, this is not always possible either. But before we figure out the other two types of tests, we have to take a slight detour toward how alternating series work and what absolute versus general convergence refers to before we can officially use these tests. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.